So Unit 5, Trigonometric Functions and Graphs. 5.1, Graphing Sine and Cosine Functions, pages 222 to 237. So our curriculum outcome for this lesson is to demonstrate understanding of the graphs of primary trigonometric functions. And our lesson objectives, there are 3 of them. First, we need to learn what a sinusoidal function looks like when graphed. Second, we're going to learn some key terminology used when referring to graphs of trig functions. And thirdly, to be able to find the amplitude and period of a trig function by looking at the equation of the function. So first, we're going to graph sine of x. And what we're going to do is use a unit circle to create a table of values to help us graph this thing. So here's a unit circle. And remember that when we're talking about sine, we're talking about the second coordinate. So we're looking at all the second coordinates. And most importantly, we're going to look at the ones at 0 degrees, 90 degrees. Over here at 180, we should label that as well. That's at -1, 0, this point, if you remember from the unit circle. And down here, this is 0, -1. So we're looking at the sine values. So here's our little table of values that we're going to put in here. First, we're going to have x, which in this case is our angle, because we're talking about y equals sine x. And then we're going to have y, which is the answer. So if I go around the unit circle, I take a look at 0 degrees first. So at 0 degrees, I have a sine value of 0. Now I'm going to skip all these angles in the middle. I'm just going to go straight to 90 degrees. So we're talking about this in terms of radians today. So we'll call that pi over 2. And that is a value of 1. When we get over here, that's 180 degrees. Well, that's pi. And that is a value of 0. Down here, we're at 3 pi over 2. And that is now a value of -1. So if we're to graph this thing, here's what we would get so far. We need to label our axis. It looks like here we go from 0 to 1 and then 0 to -1. So we'll put our 1 value here on our y, and we put a -1 down here. And we put in these values on our x-axis. So we've got 0, we've got pi over 2, an equal distance away is pi, equal distance from that is 3 pi over 2. And let's, for good measure, let's find 2 pi as well. Well, 2 pi happens to be 0 as well. So what we've got is 0, 0. We've got pi over 2, 1. We've got pi, 0. We've got 3 pi over 2, at 3 pi over 2 it's -1, and at 2 pi it's back to 0. So what we've got is this green function. Now, you might be tempted at this point to just draw this with straight lines, but this is actually a curved function. And the reason we know that it's a curved function is that if you consider this point right here between 0 and pi over 2, then you would think if it was a straight line, that should be half the value between 0 and 1. But it's not. It's root 2 over 2, which is 0.71. So it's not actually halfway in between, so it actually ends up being a little bit curved. So there's our sine function. So this is y equals sine x. Now, while we're at it, we might as well do some negative values as well. And we'll just forego the whole table of values part, but we'll go in the negative direction. So if this is 0 degrees, which it is, and we go back, we're talking about negative pi over 2. So that would be over here. And at negative pi over 2, sine is -1. We keep on going, we get to negative pi, and sine is 0. Our next value after that is -3 pi over 2, where sine is back to 1. And then at -2 pi, we are back to 0. So we can continue this as a continuous function. You could keep on going around and around the unit circle, either way, positive or negative, but you're going to find that your graph will continue to look like a wave, like we talked about in Physics 20. So next we're going to look at graphing y equals cos x, and we're going to do the same thing using a unit circle to create a table of values, but remembering that cosine x is our first coordinate on the unit circle. So again, we'll need to put in the point here, which we said is -1, 0, and the point here, which is 0, -1. All right, so here's our table of values again. We have x, which is our angle, and we have y, which is our answer. When we start at 0, we now have a value of 1. When we go to pi over 2 on the unit circle, we have a value of 0. When we go to pi, we have a value of -1. When we go to 3 pi over 2, we have a value of 0. And then back up to 2 pi, we have a value of 1. So taking a look at what that would look like, again, we have the same. These should be marked evenly, although I'm eyeballing it. You should, if you have graph paper, that would be a great idea. That would be pi over 2, that would be pi, that would be 3 pi over 2, and this would be 2 pi. And then we start x equals 0, y equals 1, so we need to put in a value of 1 up here. When x equals pi over 2, then y equals 0. When x equals pi, y equals -1. When x equals 3 pi over 2, y equals 0. And when x equals 2 pi, y equals 1. So we've got, again, what we call a sinusoidal curve. It's like a wave. If we do the same thing with the negative values, like we did with sine, going negative pi over 2, we have a value of 0. Negative pi gives us a value of -1. Negative pi, 3 pi over 2 gives you a value of 0. And negative 2 pi gives you a value of 1. So hopefully you're starting to see some similarities between the two graphs, even though this one looks a little sketchier. This graph here definitely looks a lot like our sine graph, although our sine graph started at a different place and our cos graph starts at a different place on the y-axis. They are quite similar functions, which is why they are grouped in sinusoidal curves. So just a couple of important characteristics of sinusoidal functions that you need to be aware of. The first thing is something called amplitude. Now, if you took Physics 20 or any other physics classes where you talked about waves, you know that the difference between the maximum height of a trig function and the middle height of that trig function is going to be called the amplitude. The period is the amount of horizontal distance it takes before the function begins to repeat itself. And we'll take a look at a specific example in a couple seconds here. So we're going to take a look at where in a trigonometric function we can find the amplitude and the period. When I say where, I mean where in the equation of the trigonometric function we can actually find the amplitude and the period. All right, so we're looking in GeoGebra here, just a couple functions. So the blue graph right here is our normal sine function, which we just learned how to graph. And the reason that we use that table of values is so we never have to use a table of values again. This is normally what sine looks like, starting at 0, 0, going up to 1, down to 0, down to -1, and then back to 0. So that is sine x. So let's take a look at what happens when we put 2 in front. So where we have g of x equals 2 sine x. That'll be our red function. So when we've done that, notice that our graph still looks similar. It still starts at 0, but its maximum height is now 2 instead of 1. It goes back to down to 0, and then back down to -2, then back up to 0. So what we can come up with is saying that this number, when placed in front of our sine function, actually controls the amplitude. Let's double check that. And we'll try with this purple function, p of x equals -3 sine x. So hopefully you're starting to make maybe a little bit of connection to vertical stretching, which we talked about a couple units back. Now, here we can see that our sine function looks similar but not exactly the same. So when we threw a negative in front with the amplitude, or with that number in front, the graph actually switched. Where it was positive is now negative, and where it was negative is now positive. So this number in front controls the amplitude, and it also controls whether or not it's going to rotate around the x-axis. But the important thing here as well is that this is now a maximum height of 3 and a minimum height of -3. If we zoom out a bit, you can see that the minimum height is -3 now. So what we can come up with is knowing that this number placed in front of sine will change your amplitude. Now, what's going to change the period length? Well, then if it's not the number in front of sine that changes the period length, it's probably the number that's going to be in with the x. And as you can see here, on the green function, which is h of x equals sine 2x, that our period length has definitely switched. So our period length before for just the blue function was where it starts to repeat itself. Well, When this function starts to repeat itself, that would be, it starts at 0, 0, goes up, down, and then back to 0 again, and then it goes up again. So for a regular sine function, our period length is actually 2 pi, and that's just one rotation around the unit circle. Starts at 0 and gets back to 0 in a distance of 2 pi. When we put a 2 in front, like on the green function, that's changed our period length. Our period length now has gone from 2 pi on the blue function to just plain old pi on the green function. So from 0 up to 1 still, down to -1, and then when it gets back to 0, it is now at a distance of pi, not 2 pi. So this number does exactly opposite of what you think it might do. You might think that the period length would be twice as big, but when it's a 2 inside here, our period length is half as big. Likewise, if it was a 3, our period length would be a third as big. If it was a fraction, like a half, then our period length would be twice as big. So let's try that. We'll get rid of this h of x function. We're going to plug in a sine in brackets. We have to use decimals, but we'll go 0.5x. And you can see on this new black function that instead of our period length going from 0 to 2 pi, now it takes an awful lot more distance to reach that full period length. So from 0 all the way to 4 pi. So we plugged in this black function, which is now called q of x on this program. Let me just make it bigger. So q of x equals sine 0.5x or a half x, and now our period length has changed. It is twice as big. So the amplitude of the function is the same as what we used to call a vertical stretch. And we found that in position A. So that letter that's right in front of sine x, and that could be the same as cos x as well. So we also just learned that if A is negative, then the graph reflects in the x-axis. We knew that. If that became a negative A, instead of that function starting and going up, it'll start and go down. The period of the function is normally 2 pi. When we're talking about sine or cosine, the period of the function is normally going to be 2 pi. And that period can be found right here, the letter b. If b is a whole number, the new period is smaller by a factor of b. So the normal period is 2 pi, we said. That means the new period is going to be 2 pi divided by whatever that number is. So if it was 2 pi, if this number happened to be 3, then your new period would be 2 over 3 pi. So our first example and only example says sketch y equals 3 cos 4x, showing at least 2 cycles. Determine the amplitude, period, maximum and minimum values, x-intercepts, y-intercepts, the domain, and the range. So a lot of things to do there. So what we need to do, I think the easiest thing that we've found in the past is to find some of those major points for a regular cosine graph and then just apply these two numbers to those points. So for example, cosine right off the bat, if you didn't remember, starts at 0, 1 and then goes down and then up. And so at pi over 2, that's when it's at 0. At pi over 4, at pi, it is at -1. 3 pi over 2, it's at 0. And at 2 pi, it's back up to 1. So these two numbers here, this 3 means that all the y values are going to be multiplied by 3. This 4 means that all the x values are going to be reduced by a factor of 4, so which means they're going to be a quarter of what they are right now. So our new points after those two transformations take place, the y values are the easiest to do first because we just multiply everything by 3. So we get 3, we still have 0, we have -3, and we have 0, and then we have +3. Now, our x values are all reduced by a factor of 4, so we divide everything by 4. Well, 0 divided by 4 is still 0. Pi over 2 divided by 4 becomes pi over 8. Pi divided by 4 is pi over 4. 3 pi divided by 2 is 3 pi over 8 when we divide it by 4. And 2 pi divided by 4 is now 2 pi divided by 4, is pi over 2 when we reduce it. So we can now sketch this graph, putting in the appropriate values on our x-axis and our y-axis. And knowing that it starts at 0, 3, and then pi over 8, 0, so that makes this value pi over 8 right here. And then pi over 4, negative 3. So this is pi over 4. Next one is 3 pi over 8, 0. So that's 3 pi over 8. And finally, pi over 2, 3. So this one would be pi over 2. So there we go. We've got our cosine graph. And going on the negative side, it would all be the same, but these would all be negative values. So negative pi over 8, negative pi over 4, negative 3 pi over 8, and negative pi over 2. Plot our points and continue right with this graph, because we know it looks a lot like a sinusoidal graph, which should be a smooth curve. Mine's a little jagged, but a smooth curve moving up and down from a maximum height to a minimum height. So now we can answer these questions. It says determine the amplitude. Well, the amplitude is from the middle to the top, so the amplitude is 3. That's also right here in your function. Your period is from where it starts to where it begins, or where it starts to repeat itself, and that is from 0 to pi over 2, so our period is pi over 2. Now let's double check. We said that should be the same thing as 2 pi over b, and our b is 4, so that's 2 pi over 4, and that gives you pi over 2. Maximum and minimum values, where our largest value is 3, so our max is 3, and our min then is negative 3. That's as low as it gets. X-intercepts, well, our x-intercepts are pi over 8, 3 pi over 8, and on the left-hand side, negative pi over 8, and negative 3 pi over 8. Our y-intercept is at 0, 3. And then domain and range. Well, our domain is how far it goes from left to right. Now, if this is a regular cosine function, it goes on forever from left to right. So we're saying XER. Our range, however, is a little different, because our range is how high it goes and how low it goes. So that means we're talking about our y being less than or greater than 3. Sorry, greater than negative 3, but less than or equal to 3. And there's all those things. So in order to sketch this graph, I think the easiest thing for you to do is pick those main points that we've been talking about in previous lessons, and then apply the 3 and the 4 to them. So in summary, we know the graphs of both sine and cosine have a similar shape, and that's called the sinusoidal shape. So for sine of theta, we know that our graph starts at 0, goes up, down, and then back to 0, and that these points start at 0, go to 2 pi, so right in the middle would be pi, in the middle of that would be pi over 2, and this would be 3 pi over 2. Now, this sort of thing just comes with practice, knowing the shape of them and knowing where these normal points are, but all these points were found from the unit circle, so you really need to know your unit circle. And likewise, there is a negative side to this function, which just follows the same pattern. Instead of going up and then down, it goes down and then up. For cosine, the shape is the same, but it starts in a different spot. So it starts up here, and then it goes down and then up. So this is 0, this is pi, and this is 2 pi. And again, we have a 3 pi over 2 and a pi over 2. Now, in both these cases, they have the same amplitude and the same period length. And we said the amplitude is, in this case, 1. And that's normal for a sine and cosine graph. And the period length goes from 0 to 2 pi. So the period length is always 2 pi. Or, if you want to think about it in degrees, 360 degrees. And we know that we can find the amplitude and the period of a sinusoidal function by looking at either the graph, like we just did, or by the equation. And you have to remember that the equation would be something that looks like this. Or if we're talking about cosine, y equals a cos bx, where a is your amplitude in both cases, and it can be negative, which just means this graph flips upside down, and b is the factor that your period length is decreased if it's a whole number or increased if it's a fraction. So remembering that your new period length is going to be 2 pi over b. So that's a summary of what we did. A long video, but pretty basic stuff if you've done the previous lessons on any sort of transformations of functions. So assignment is on pages 233 to 237, and we'll see you in class tomorrow.